Hello, I'm Shelli Brunswick, the Chief Operating Officer at Space Foundation. And today we're going to have an amazing fireside chat with Ms. Pam Melroy, the Deputy Administrator at NASA. And we're going to talk about partnerships in the space ecosystem. Thank you, Pam, for joining us today.
Well, thank you so much, Shelli. I'm excited to be here and look forward to our chat. I've got a few comments to start with. I just want to say that we have had an amazing couple of years at NASA. I think everyone knows that NASA has a mission in human space flight and a human-rated spacecraft to go beyond Earth orbit back to the moon, Artemis 1, last year. But in addition to that, we continue to send crews to the International Space Station, and in the last 2 years have launched 6 operational missions to the space station with crews on board to do science. But we have other aspects of our mission as well, in particular space science. And I think probably anybody who is online is familiar with the James Webb Space Telescope and the astounding pictures that we have received from that are peering back into the universe and looking for the secrets of life on other planets in our galaxy. But in addition to that, we also have more than 24 satellites studying the Earth, and we have launched several to study the Earth's atmosphere and especially to understand weather and the impact of water and land on climate. In addition to that, we have a full research portfolio in space technology and aeronautics technology, and we're working on an aircraft called Quest, which is a low supersonic boom demonstrator. So the goal is to shape an aircraft in a way that a sonic boom, instead of rattling the windows and maybe even breaking them, will sound a little bit like a door closing. And that's a big deal because right now you can't fly supersonic over the country. It's because of the damage that it can cause. So if we can show how to do this, we can help the next generation of commercial aircraft fly supersonic. And I think all of us would love a trip across country in half the time that it takes today. So we have a very, very full list of things that we have been working on with more to come. One of the things that we're really proud of is the economic impact that NASA has. We impact about $71 billion of economic output in the United States, including 340,000 jobs across multiple industries that support the development of space and civil space. And we're very, very proud of that. We think that that is a critical aspect of one of the jobs that we have. We are here to advance science, but we're also here to impact terrestrially, benefit humanity and national posture in science and technology and economic output, and of course, to inspire the next generation in STEM. We do have some big challenges ahead of us, though. Some very exciting things are yet to come. In fact, just tomorrow, will mark the 1-year anniversary of the release of the first image from the James Webb Space Telescope. And so tomorrow, we're going to have another eye-popping day where we will release some really amazing images. But later this year, we'll be returning a sample from an asteroid. We are working to reduce emissions on airliners by up to 30%. We're preparing to go back to the moon in preparation to send humans out into the solar system, with the next destination being Mars. So this is an amazing mission that we have. But for the theme to today, we really do this all in partnership with industry, with academia, with nonprofits, and with our international partners. Wonderful African proverb that says, if you want to go fast, go alone. If you want to go far, go together. And we are committed to going all the way in partnership with others. So we're excited to be here to talk about that.
Fantastic. Well, we're going to talk about many of the things that you just shared. We're going to unpack them a little bit. At Space Foundation, we're a U.S. nonprofit that advocates for the space industry. And what we like to focus on is returning to the moon, going on to Mars and beyond, but also how we bring that space technology and innovation back to Earth. So with that, there's a lot of things you said that are exciting about returning to the moon. You have Artemis, you have the Artemis Accords, Lunar Gateway, cislunar orbit. So let's start with the most recent news that we saw, which was India and Ecuador signing the Artemis Accords. What is the role of the Artemis Accords and those international partnerships?
Yeah, it's a great question, Shelli. It's kind of interesting. Space for a long time has just been the sole province of a few governments on Earth. And now what's happening is through investments that NASA has made and others, we have built an amazing commercial space industry that's capable of doing extraordinary things without needing the additional help from the deep government expertise that we have. And so those partnerships are very exciting, and they're also changing the world. And more countries are getting the capability to go to space or beginning to see how space can impact industries in their country, and they're interested in getting involved. So these are two great examples. Recently, Ecuador signed the Artemis Accords, and they're an emerging space nation. They are interested in investing. India signed the Artemis Accords, and they're a mature space nation with launch capability, and they're approaching the ability to be the next country that can launch humans into space. So what are the Artemis Accords? Well, we don't have very much law in outer space. There's the Outer Space Treaty of 1967, a little outdated. But as we go forward, we should have some agreements about how we're going to behave towards each other. Principles like transparency, sharing data, not interfering with each other, and ensuring space is available to all. And those are the principles that are embodied in the Artemis Accords. So we've been working with our partners just to agree on some of those basic principles and what actions we might take going forward. So we are up to 27 countries that have signed the Accords, and that's very important for the future.
Fantastic. Well, that ties into Artemis. You know, a couple months ago, you announced the Artemis 2 crew, woman, African-American, our Canadian allies to the north. Where are we with Artemis 2, as well as the Artemis program in general?
Right. Artemis, of course, is the twin sister of Apollo, which is very appropriate. I think we're taking the next step. Artemis is not Apollo, though. The goal of the Apollo program was to land a man safely on the moon and return him safely to Earth. Artemis is very different. The goals of Artemis are to actually begin long duration exploration of the solar system, starting with the nearest celestial body, the moon. So we're finally ready to take steps out for human sustained presence and exploration throughout the solar system. But we need to practice. We have never done anything like this before, where we had a sustained presence on the surface of another planet. So we're going to practice only 3 days away instead of 6 months away, which is how long it takes to get to Mars. And the Artemis program will land the first woman and the first person of color as a part of that program on the moon, because we are going with a representation of everyone on Earth. And as you pointed out, the next mission is Artemis 2. The first mission was an uncrewed test flight. This will be a crewed test flight. And it's a symbol of a representation of how international Artemis is as a program, like we did with the International Space Station, to have a Canadian astronaut as a member of the crew. So the crew is in training. They're working crew egress. They're going to be going out to San Diego and practicing what it would be like to get out of the vehicle in the water and see the ship that they will be getting into and things like that. So in addition to that, we continue to process the spacecraft Orion that will launch on the SLS rocket. And we're making a lot of progress, and we're excited for Artemis 2, and that will be late next year.
Fantastic. So I'm going to stay on the moon because there's another piece of the moon architecture called the Lunar Gateway. What is the Lunar Gateway, and let's tie in. You've talked about Artemis, but these aren't just NASA programs. You have industry partners and academics around the world. We're broadcasting live from the Arizona State University facility right here in Washington, D.C. So tell us about the partnerships that are part of Artemis as well as Lunar Gateway.
Right. Well, we have great partnerships, both industry and international for throughout the Artemis program. But Gateway is an orbiting logistics module and also a research facility that we intend to put in orbit around the moon, in quite a unique orbit, actually, around the moon. And it will provide a location for the crew to assemble the logistics that they need to and can get into a lander that will go down to the surface of the moon and then come back up. And then Orion is the spacecraft that will bring them home. So Gateway, we've made great progress on that. We actually just finished the preliminary design review just this spring. Elements of it, we have a propulsion element that's actually going through testing with the largest electric thrusters that have ever been put in space. And then we've been through critical design review on the HALO module, the habitation and logistics module. But we have international partners as well. The Canadians will be contributing a robotic arm to this station around the moon. In addition to that, the Europeans are building an IHAB, a habitation facility that will allow longer duration stays for our crews when they visit Gateway. And in addition to that, Japan is building the environmental system inside the IHAB. So this is truly an international effort, very reminiscent of what we have done with the International Space Station.
Fantastic. So one of the questions that came up at Space Symposium that Space Foundation puts on every April in Colorado Springs and other space conferences is cislunar orbit. What does it look like? Who are the participants? And what is NASA's role in a cislunar economy?
Well, I'll take a step back for a moment and talk about, I mentioned about the growth of commercial space. So what we're seeing is a massive impact in low Earth orbit. We see companies that are putting up constellations, communications constellations that enable internet access and other forms of communication around the world. We're also seeing interest. There are 4 companies that NASA has partnered with that are interested in building commercial low Earth orbit destinations. That's commercial space stations in low Earth orbit, which we hope will be ready in about 5 or 6 years. And that's amazing. There's so many things happening in low Earth orbit. So the question is, how is this going to extend out as we push out? Is industry coming with us? They absolutely are. As you pointed out earlier, we have industry partners as well. Northrop Grumman is helping us with the Gateway, as well as Aerojet Rocketdyne. But in addition to that, we are partnered with SpaceX for a lander that will be used on the first landing to the surface of the moon. But we recently signed a contract with Blue Origin to have a second lander, and we will have a competition and see how that works out. And those are very different kinds of partnerships because NASA won't own the lander. The company will own the lander. So we partner in different ways depending on whether there's a commercial model around that. Transportation is a great model. And an example of that is that we know that we want to do a lot of science and technology before we send humans. So we have a commercial lunar payload program, CLIPS, that is basically a service that we will provide payloads, technology, and science demonstrations. And we're working with a couple of companies, including Intuitive Machines, Astrobotic, and Firefly right now, and Draper, who will be landing commercially on the surface of the moon and delivering these payloads. And we hope to see that program start this year. So we think transportation is a great business model. We think communications is going to build. But in addition to that, NASA would like to develop infrastructure that supports our astronauts for longer stays, but that infrastructure can also support new business models and new companies operating around the moon and also on the surface of the moon.
So You have nothing going on the moon is what you're telling me and our audience. No, amazing. All the things that are taking place with NASA and the moon. But let's pivot on now. Let's continue that ecosystem and go to Mars. So you have a strategy on moon to Mars, and you briefly said, you know, the moon is a good test ground for moving on to Mars. You just came out with your architecture for that. What does that look like? And again, share with our audience, who are those partners that are included in that going on to Mars?
Yeah, we have extraordinary partnerships, both with industry, academia, in particular in the area of science, and our international partners. So we have been consulting with our industry and international partners on the strategy, on what our objectives, what do we have to prove before we're really ready to go to Mars? Because we're not ready to go yet. There's a lot that we need to prepare for. We need to do some technology demonstrations around propulsion systems that are lighter and more effective. Nuclear propulsion is likely to be the propulsion source that will take us on to Mars because it's a much longer trip. So we're partnering both with the Department of Defense, and also other government agencies, but also with industry as well on developing nuclear propulsion and nuclear power sources. That's really important because the further out in the solar system you get, the further away you are from the sun. And so solar power is less effective. So we really need to be looking at some of these low mass, but very highly powerful systems. So the intent is actually to practice on the moon, but we recognize that new technologies are emerging so fast. We want to have an evolving architecture. So once a year, we're going to take a snapshot and say, anything new, anything changed? Do we have a new international partner? Do we have a new industry partner that is bringing something new to the table? And so we have capabilities that we know we have to have, and we've mapped those out, and everyone agrees those are the things we need to have. And what's great about that for our partners especially is they have the opportunity to look ahead and see those areas where we don't have a capability yet. And that's where their opportunity is to partner with us, either industry or international partnerships.
Fantastic. So what you're highlighting is tech insertion, where a company could come in, insert their technology into this space architecture and be part of the future of going to Mars. So let's talk about tech transfer, which is when technology comes from the government into industry. And that's going to pull this whole space ecosystem full circle now back to Earth, because most people don't realize that we're using space in our daily lives. For me, one of my most favorite forms of space technology is thanks to NASA, and that's fire retardant clothing, because my husband was a firefighter for 30 years. And thanks to you and the great people at NASA, he got to come home every night. But that's just one form of technology that NASA is credited with. What are some other forms of tech transfer that NASA has and has benefited humanity?
Well, the list is long, and it's very interesting. My background is as not just an astronaut and test pilot, but also as a technologist. And so the history that NASA has had, and it's a few of my very favorite examples. NASA basically had to invent software engineering to do Apollo. That was an emerging capability, and the ability to do targeting and guidance, navigation, and control really required computational power of a computer. And it was a new and emerging technology in the 60s. And so NASA basically invented software engineering as a discipline. And of course, what that led to is that capability in the next decade and the decade after that laid the foundations for the development of the internet, because we had that strong computer science ecosystem. One of my other favorite ones that's a great example of how it benefits outside just the space industry or what you're doing is inside your phone. The camera is on a little chip, and that was developed by NASA to have cameras that could look back at the Earth and study it for scientific purposes. And they needed a very small, lightweight camera. And rather than a big lens, they invented basically this camera on a chip. And now, of course, think of all the business models that count on having cell phone cameras, right? It's built into so many apps and so many other capabilities. really what we found is when we focus on solving problems that benefit the humans in space, that spins off. Another great example of that is telemedicine, food safety, both areas that were basically invented by NASA. What we think as we go forward, because we've seen this on the space station, as we're trying to recycle water, is that it's having an impact here on Earth in drought-stricken areas about how to recycle water, how to manage a water ecosystem. So the list goes on, but when you think about keeping people alive in a very harsh environment, that has a lot of applications here on Earth.
Absolutely. And for those of you in the audience that are innovators, entrepreneurs, investors, you can go to the NASA Tech Transfer Office and look for thousands of patents that are waiting to be commercialized by you, which leads me to our next question, which will be close to our last question, unfortunately. What are the career opportunities? You've talked about science and space and rocket engineering, but there's also like investors and entrepreneurs. So where do you see the future of the workforce for the space industry going?
Absolutely. It's actually an incredible ecosystem. So certainly there is the business aspect that you mentioned. There is a huge appetite in space investment for people who understand it or appreciate the impacts of having global access to data, around the world. But in addition to that, as I previously mentioned also, space law is an emerging field. The other thing I'd like to highlight is we're building more and more spacecraft and more autonomous systems. We need a skilled workforce, not just STEM graduates with an engineering degree, but people who have certifications and have gone to a community college or a vocational school. And it's fascinating work building a satellite. We have technicians wearing Google Glass and laying out the insides of a satellite over and over and over again. It's really interesting and fun work. And so there's a lot of capabilities in every possible aspect that you can imagine. Personally, I'm pretty excited about those who tell the story and do the art. I think that's something that we really need more of.
Fantastic. So there's a lot of opportunities, high school graduates to PhDs and everything in between. So our last question is really going to focus on the diversity of your career. We have an amazing audience that's also diverse. We have some young students watching today. What are some of the lessons that you've learned in your career that could help them find their way into the space industry?
Wow. I think the most important thing is just if you're interested, you should talk to people, ask questions, get out there. Watching an event like this can teach you so much about what opportunities are out there. But in my career, one of the things that I think is incredibly important, space is complicated. And as a result, it's really important that you have access to a lot of different opinions about things. When you're doing something hard and doing something for the first time, getting a lot of advice is a really good idea. So that's one of the core principles that we have at NASA, is to listen to each other. It's really, really essential. It's important to our safety culture, but it's also important when you're trying to do something no one has ever done before. But the personal lesson that I've taken from that is you have to know when to listen and when to act. And so listening to advice is great. And then you got to do something about it. So do something.
Absolutely. And I will share, Pam and I did have some similarities in our career. We were both in the Air Force.
Yes.
She went on to become a NASA astronaut. I did not, but we did meet through Women in Aerospace. And what I want to highlight is if you're listening today and you're interested in being part of the space industry, there are amazing organizations that you can participate in, not only in your local area, but also globally. Space Generation Advisory Council, Women in Aerospace, United Nations Office of Outer Space Affairs has a Space for Youth and a Space for Women program. So find like-minded individuals like yourself and nourish that excitement about space. And the other big thing we'll say is find a mentor. And there are some great mentoring programs out there as well with Space Generation Advisory Council, WomenTech Network, and the United Nations Office of Outer Space Affairs. So thank you,
Shelli, that's a great point. And I'll just say it again. If you want to go far, go together.
Well, as we wrap up, Pam, did we miss anything that you'd like to highlight today?
I'm just excited to see this next generation. I was inspired by Apollo, and I hope that you are inspired by Artemis. And I hope to see a tidal wave around the earth of students who are interested in getting involved in space.
Fantastic. Well, I'm Shelli Brunswick, and this is Pam Melroy, and we look forward to seeing you around the galaxy.